Good morning, everyone. Welcome to the second annual user forum for the Aspect project. My name is Sam Granger, and I am a research fellow from the University of Leeds and a member of the Aspect project team, and I'm going to be moderating this session today. It's a pleasure to have you all here. For those new to the project, this is the second set of sessions organized by the Aspect project, which loosely stands for Adaptation-Oriented Seamless Predictions of European Climate. We had two sessions last year, which you can find recordings of on our website. And over the next 3 days, starting today and continuing until Thursday, we'll have 3 1.5-hour sessions packed with insightful presentations and discussions. This forum is a vital platform for dialogue and the co-development of knowledge. It brings together scientific experts, a wide range of information users, and colleagues involved in translating complex climate information into useful tools, often referred to as purveyors. Today's session is all about making future climate information easy to understand. We'll briefly introduce the project and explain in a very accessible way some of the science behind climate prediction. And then towards the end, we'll discuss with experienced users how this information informs and feeds into organizational activities and decision-making. Please remember to keep your microphones muted and raise your hands for questions, or feel free to post them in the Q&A. Note that this forum is being recorded, but only keynote talks and project partner contributions will be publicly disseminated. The discussions will also be recorded, but solely for internal purposes. Okay, so I'm now going to hand over to our first speaker, Marta Terrado. Marta is one of the coordinators of the Aspect project and a senior researcher in the Earth Sciences Department at the Barcelona Supercomputing Center in Spain, where she co-leads the knowledge integration team. Marta is now going to briefly introduce the project. Is that okay, Marta? Are you ready to share your screen?
Yes, I am.
Lovely. Over to you then. Thanks very much. Thank you.
Okay, so I'll go ahead and hi, everyone. I see that many people have connected. This is lovely. And as Sam already said, my talk will be very brief, and it's just to provide an introduction to the Aspect project. And I will focus mainly on the motivation for this project. So I'm not going to go into detail on the science that's going to be developed, because there will be other speakers for that. But I will try that you at least have a very a take-home message, which is the main idea of what the project aims to do. To start, I will just introduce the project briefly, what it is. Aspect is a Horizon Europe project. It's a research and innovation action. And the main objective of this project is to produce and improve seamless climate predictions that cover the next 30 years. And then embed these predictions into into climate change adaptation decisions that are important for the society. As a main output, Aspect will provide a delivery system for climate information that will be tailored, taking into account the user requirements. And when we mention user requirements, it's because we try to put the users in the center of the project, and we do so in 2 different ways. First, by collaborating very closely with super users, what we call super users, and I will introduce this concept later on in this short talk. And then also collaborating with others so with the wider community beyond the super users like you. And this is actually why we are organizing these annual user forums in the project. The Aspect project is led by the Barcelona Supercomputing Center. You can see the people involved in the coordination below. So with Albert Soret is the coordinator of the project. Myself, I'm co-coordinating with Albert. And then we have support for the coordination also from the UK Met Office, particularly from Jason Lowe, who is the project scientific coordinator. The consortium is formed by 11 partners. You can see the logos of the different institutions on the right in this slide. And the project started 1 year ago in January 2023, and it's going to run until the end of 2026. And here I will start with this concept that I was mentioning, that for me, it's what I think it's the most important message to take from my presentation, which is the rationale behind Aspect. And to explain that, I will ask you to imagine that you are taking a picture, you are in front of a landscape, and you try to capture the different elements that you can see in the landscape. So for instance, Closer to you, you have some flowers, which is element number 1. Then you have another element, number 2, which is an animal that is behind the flowers. And farther away from this animal, you have some trees, some spruce, that you also try to fit into the picture. Then, of course, this is a matter of the focus. So if you try to focus on the first element, as you see in the first picture, and then only capture this, you will be able to see very clearly the flowers in the picture, but then the rest of the elements, number 2 and 3, the animal and the trees, will be blurred in your picture. So you will need to increase the field depth and increase this focus. And then you will be able to capture, for instance, element 1 and 2. And the result of this increasing the field depth will be that you can clearly see the flowers, you can clearly see the animal, but still the trees are blurred behind. So this would require for you to focus, to increase this field depth, and then you can focus on the 3 elements and see everything on the picture. So I use this picture thing just for you to now change a little bit your mindset, and instead of a picture, think of a forecast. So when we talk about climate forecasts, all of us are very used to use these mobile applications where you can check the weather that it's expected for the next days, for today, for tomorrow, for next week, even for a couple of weeks, but not much beyond that, because after 10 days or so, we tend not to rely on the predictions that we get. Okay, this is a part of the science of climate forecast, but then there are climate scientists that focus on other timescales, not only the short term, but also timescales that go beyond these 2 weeks. One of these groups of scientists that do research on climate predictions are those that focus on seasonal predictions. And seasonal predictions are predictions that gives you an idea of how the climate's going to change in the next 1 to 6 months. Then there is another group of scientists that focus on another timescale, which are called decadal predictions. And with decadal predictions, these scientists can get information about what's going to happen in terms of climate for the next 2 to 10 years. Normally, the community that focuses on seasonal predictions is different from the community studying decadal predictions, and also the methods and the models that they use are different. And we can have another group of scientists that focus on how the climate's going to change from the next 30 years and beyond, so much more farther away in time. Normally, these 3 groups are not connected, and as you can see, in between number 1, 2, and 3, we have some gaps. We have some information, so what's going to happen from 6 months to 2 years, and what's going to happen more or less from 10 years to 30 years. There are some gaps of information that are not appropriately addressed by these communities. So this is the motivation of the Aspect project. What we will try to do is to extend these predictions. So instead of finishing them in 6 months, bringing them farther away into the future so they can merge the second group of predictions, and the same between 2 and 3. So the project will try to connect all these timescales, and the aim is that finally we get what we call the seamless climate prediction that has the whole picture, that has a focus on the 3 elements, and that these will be types of predictions that can provide information that goes from a few months or a few seasons to decades into the future, so we can have the full picture. And why do we want to have this? This is because in the end, the needs of the users of any sector don't stop in one of these timescales. When a user makes a decision, needs to consider these different timescales, needs to see the full picture, and not just, make a decision that works for one of these timescales, but also that it's sustainable with time. In Aspect, we have this first year, we have worked with 3 super users. And who are the Aspect super users? So they are organizations that are working closely with the researchers in the project to co-produce climate information that spans from seasons to decades, and that also cuts across these timescales. And we do this to help these users to make better informed decisions for adaptation. So far, we have been collaborating with 3 users in 3 case studies. One case study is about agriculture, and for that we have on board a winery from Spain. Then we also have another case study on governance that we say, and this involves a regional agency in Emilia-Romagna that is part of the mission for climate adaptation. So this region needs to adapt to climate change and propose appropriate measures to do so. And then a third super user from the finance sector, who is a Clear Glass, which is a pension sector in the UK. And also during this year, we have launched a call for super users. So we want to get 2 additional super users on board, and the winners were communicated recently at the beginning of this year. So now we will have on board also Save the Children and the British Red Cross that are going to introduce themselves in this first session of the user forum. To finalize, just to introduce the user forum, as you know, this one is the second one. We had one in 2023, and now we have this annual one in 2024. And the main objective of having the forums is to build a community of practice on seamless climate information. Anyone interested in understanding climate predictions can join the user forums, because the idea is that we will learn together on how to apply the result of the project, so these predictions, for decision making. No specialized knowledge is necessary to participate, because the idea is that we can learn together, we solve doubts, and we discuss different issues. And the objective of these forums is first to provide a platform for this collaboration, also to promote a deeper understanding of climate information and promote the uptake of these predictions by different socioeconomic sectors, which are represented by all of you. Then we expect also that these forums will allow us to explore how can we upscale the results that we get with these 5 super users to other sectors, to other users, to other levels of decision making. And finally, the aim is also to share knowledge and information to build capacity on how to use this prediction. And if we find this interesting, we can even organize some thematic groups around the different case studies, so we can discuss more in detail how a particular case study applies to your needs. And with all that, I finish here my presentation, and back to the moderator, Sam.
Thank you so much, Marta. That was great. A really engaging introduction to the project. Right, so now I'd like to introduce our keynote speaker, Professor Francisco, also known as Paco Dobles Reyes, who is the director of the Earth Sciences Department at the Barcelona Supercomputing Center. Paco is going to explain some of the science behind climate prediction. So I'll hand over to Paco if he's ready. Are you ready to share your screen, Paco?
Yeah, I am. Let me give it a try.
Yeah.
Yeah, okay. Thank you.
Thank you.
Thanks, Sam. Good afternoon, everyone. And I would like to thank the organizers of the user forum for giving me the opportunity to speak to all of you about some of the things I've been working on in the last few years, quite a long time actually now, and you'll see what I mean with this in the first few slides that I'll show here, and also to all the colleagues in Aspect and in other projects that have contributed with material for this presentation, and I tried to name them in the slides, but for sure this won't be completely fair, because lots of people have contributed with ideas and figures and text for this presentation. My name is Paco Dobles Reyes. I work at the Barcelona Supercomputing Center. I'm an ICREA research professor at the BSc in Barcelona, and I lead the Earth Sciences Department, which is the department that is coordinating the Aspect project along with the Met Office. This talk it was intended to provide an introduction to climate prediction. There will be some elements of climate prediction and concepts and an entry-level information. But what I tried is to put all this in a context that where climate predictions contributes to the development of climate information in the co-production of this information, along with those that are vulnerable to climate variability and change on timescales that range from seasons to a few decades into the future, to support them in their decision-making processes. There will be many more details about climate prediction, in particular the work that is being done in Aspect in this session tomorrow of the user forum that will count on the presentation that Freya and Bina have prepared, and that I hope you'll find also very interesting with all the very useful details that they have gathered. This is the outline of the talk. So I'll focus first on what we are looking for in terms of climate information for the future in a very broad context, and also what it takes to produce and deliver climate information based on the climate predictions that are being made both in research and in operations. Operations meaning a regular production of climate data for the future by operational institutions, mainly Met Services. In third place, I'll say a few words about climate prediction as a source of climate information. And finally, I'll focus a bit more on climate services and what it takes to provide climate service that ensures that there is quality information delivered to those that need it and that make the final decisions. While preparing the presentation, I rescued these slides, this image that appears here that was produced in 2011. Which I was very surprised when I realized that it was 13 years ago, and this was an image that we made up. Of course, it didn't make it in the front page of the Times at the time, but it was the way we imagined near-term climate prediction, the information for the next 10 years in 2011, and. At the time, it was pretty clear that Northern Europe was warming faster or more than Southern Europe. And also, we had already a pretty good idea of how we were expected climate to change in terms of anomalies of temperature at the global scale for the second decade of the century. And we also imagined how climate information for later in the future would be produced and delivered, and that's what we thought about. So somehow we imagined transparent screens, which hasn't materialized, but what is materializing is what appears in the text of this figure. So somehow we have a certain degree of committed climate change already that is hitting hard, and what happened last year, that was without any doubt the warmest year in a historical period at least at the level of the global mean temperature. And we are also approaching that there is more warming coming our way, and somehow while we were a bit naive in imagining transparent screens for delivering information, we were not that naive in the imagining what the future was able to produce. Excuse me. At the in the next 20 years, and that was imagined in 2011. So somehow we thought that this kind of information was going to be expected by the third decade of the century, and we found out that actually this information is being delivered right now. So we are now having information for the evolution of the climate at the global scale for the next year, for the next 5 years, or for the next 10 years. And even we have estimates of where we are at in terms of global warming levels at this time of the in this century. These are examples taken from on the top left, the decadal predictions produced by the Met Office that are delivered in this case for the global mean temperature for 2024, where the threshold of 1.5 with respect to pre-industrial, the pre-industrial period is likely, or it has a certain likelihood to go over. And on the right, you have a similar focus this time on not only for the year 2024, but also for the next 5 years and the 5 years afterwards by the Barcelona Supercomputing Center. And at the bottom, there are different estimates of what the current global warming levels, so where we are in terms of the actual degree of warming at the global scale at the present is. And this is from the Met Office that has a very interesting dashboard explaining how to obtain these estimates. In all cases, you see a bar at around the 1.5 degree warming level, which is somehow one of the drivers behind the production of all this information. So 1.5 was set as, from the policymaking point of view, as one of the targets to avoid by the countries that are part of the UNFCCC system. So basically the United Nations framework for the discussions about climate change. And we found out several institutions that are involved in Aspect that those policymakers were very interested in knowing where we are at, and also where we are getting in terms of global warming in the next few years and the next couple of decades. And that somehow we have tools now to produce this kind of information. We have estimates of how reliable this information is, and we have now ways to deliver this information to those that are showing interest into it. And that this is information mainly for policymaking interests and driven by those global discussions about the climate change. However, the decisions that are vulnerable and sensitive to climate are a bit more complex than this, at least in terms of climate adaptation, which is the main driver behind Aspect. And the production of the climate information for adaptation in particular, and mitigation is not far behind, follows this kind of idealized loop that we see in this figure. So if you can see my mouse here at the top, close to number 2, this is the place where the climate data that is being produced by all these institutions that are observing the climate and are making simulations for the climate into the future are being delivered and provided to those that can start processing this data in number 3 by adjusting some of the systematic errors that we know that these simulations have. They also hand it over to others that estimate the focus quality, so the quality of the data that is being delivered for, in number 5, tailor climate information using this data. And that moves on into number 6 to develop climate services products that are somehow co-produced with those that are going to use them for their own decisions. And the loop starts again by, in this interaction, identifying new user requirements, new needs, new ways and new desires in terms of not just how the information is being delivered, but which other variables, which other experiments are actually missing. And the whole loop starts again. this is that loop is in part reflected in some of the thinking in the climate research community, and this is one figure taken from the recent IPCC report that was published in 2021, in which we can see a conceptual diagram where the construction of climate information is illustrated. So climate information starts in this diagram from the different sources of climate information that includes data, but also understanding, the expertise of the climate community, observational data, and many other sources. And all this is synthesized into pieces of climate information that enter the a user-oriented and user-driven climate information construction, so that the climate information becomes user relevant. And if you notice here on the left of this diagram, we can see that there is a loop that goes up and down, and that tries to illustrate that this process is iterative. What happens in practice is that very often what we see is that the part of the loop that goes down is gathers a lot of attention, and the part of the loop that goes up here on the right with the red arrow is much less efficient, and it's lacked and probably not as strong as it should be. So there is an imbalance in the way climate information has been produced in many cases in the past. So somehow what we have is an opportunity to start thinking as if things could happen upside down. So, and that this is one of the challenges that the Aspect project is trying to bring to the front and address. And it's far from easy to address it. So what happens if we start the whole process by considering what the user relevant climate information actually requires, and walk all the way backwards? So in this case, going down to the identification and the design of those climate information sources. And somehow in Aspect, this is being tried to be put together by paying attention to the timescales that that Marta has already described before, and that are the ones that are being covered in Aspect. So that the seasonal, multi-annual, decadal, and multi-decadal timescales, and each one of these 4 sets of climate predictions have been in the past and are still being produced separately by slightly different actors, by communities that are not always fully connected. And this is one of the aspects that one of the challenges that Aspect is trying to address. In any case, when addressing the formulation of climate experiments and the operational for the operational delivery of climate data for those timescales, one has to bear in mind that there are different drivers for the generation of these the climate data for the future into those timescales. The farther left we go into the diagram, in the initial conditions of the simulations play a major role, similar to what happens in the in operational weather forecasting. Nobody would try to make a weather forecast without taking into account what the weather is today, and that this is the way weather forecasting is being made, not just using physical climate models, but even using machine learning based numerical weather forecast systems. However, as we move towards the right, the role of the initial conditions, the role of the present state of the climate system becomes slightly less important and gradually less important, and the role of the forcings, forcings that include both anthropogenic and natural forcings, becomes increasingly important and relevant. And this is the case, for instance, when we go to decadal predictions and multi-decadal predictions, and even long-term climate projections, which are the ones that we are much more familiar with if we have been working in the climate adaptation world in the past. On top of this, there are other physical drivers in the climate system that play a role, and those that play a role in are different depending on the time scale into the future that we consider. So, for instance, we know that ENSO is one of the main drivers of both seasonal and multi-annual decadal forecasts. While, for instance, at longer time scales, for instance, in decadal forecasting, the Atlantic multi-decadal variability, which is an indicator of the states and evolution of the North Atlantic mainly ocean, is one of the relevant drivers of the evolution of not just the Atlantic Ocean, but also the continents that are surrounding it. And in all cases, climate change is affecting the information that we are producing, and that happens even now when we are making weather forecasts. So before getting into a bit more detail into how all these systems are working, I would like to start with some early examples on how information for the near term, for the next few years or a couple of decades into the future, was being formulated at the beginning of this century. This is a very nice example by Juni Raisanen that was using climate projections from the third phase of the climate model intercomparison project, where he took those climate projections that were run at the end of the 20th century to make the estimates of the evolution of temperature and precipitation in southern Finland, and that was done with sake of formulating adaptation plans at the time. And it was very interesting to see that he was already considering the changes per decade. Those changes were gradual. Here at the in the horizontal axis, you have the different decades that go from 2001 to 2010, 2011 to 2020, 2021 to 2030. It's interesting to see that we can already validate, we can compare the second box and whisker plot that appears in each one of these two panels, the one that covers the period 2011 to 2020. And some people have already done this thing and compared those estimates of the anomalies at the regional local level with the observations that have been gathered over that time. So somehow what I'm trying to say here is that there was already a demand for information for the near future with a more granularity than saying what the climate change is, how the climate change is going to affect climate at the end of the century. And also we have now the opportunity to start verifying the information that was formulated at that time. A few years later, during the preparation of the publication of the fifth assessment report of the IPCC, then the decadal prediction was emerged as one of the sources of climate information for the near future. Decadal prediction was a sort of mix between the large experience that existed at the time on seasonal prediction, so that those predictions that try to forecast the evolution of climate for the next few months, and the information and the large experience that existed at the time to formulate climate projections, so the evolution of the climate in the long term until the end of the century. What we see here are estimates of the observations in solid black, and we also see a decadal forecast that was formulated at the end of 2011, which is this black shade that appears here with the vertical bars. And even there was a decadal prediction formulated for the next 30 years, which is the red area that is covered in the panel. So already at the time, there was the intention of trying to design new ways of generating climate information for the next 10 to 30 years, similar to what we are trying to do now in Aspect. All this was put in the framework of the climate projection, so the baseline of the sources of climate information for the future years and decades that appears in light blue with the ensemble mean of all the models that contributed to CMIP5, so the fifth phase of the CAPL model intercomparison project, here in white in the middle of the light shades. So somehow decadal predictions emerged as an additional source of information for what would happen in the next 10 years. And that was an additional source of information for the next year that had to be merged or understood in the context of the seasonal forecasts that were being produced operationally at the time. The shades that appear in the figure before correspond to uncertainty estimates. Uncertainty in the sense that we try to know how much uncertain our estimates of the future are going to be. So those estimates are going to be somehow driven by a lot of factors that are not fully observed at the time of when we make these forecasts. The reason is that somehow we can't observe the focus, the climate system perfectly, and also our models, the models that are being used to formulate all these simulations, are not perfect, so that we need to consider many models, and even we need to consider many different simulations that take into account the uncertainty in the initial conditions that we have. Somehow this is illustrated in a very theoretical way here using a Galton board, which is this sort of game that you can buy in many different toy shops, that is illustrating in what way a process that goes through many different drivers and factors that are in affecting the fall of the evolution of each one of these instances distributes itself along following a Gaussian distribution. This is the representation of the different futures that we might have, for instance, for the next 10 years that will be distributed along this Gaussian distribution. This is illustrated here on the left with a Galton board that is representing, for instance, the probabilities for having a dry or a wet future in a particular area, which is the probability of each one of these futures is illustrated by the vertical green bars. However, if we have an influence that is tilting the Galton board towards a side, the distribution that we'll get is going to change. So what are those large-scale influences? Those influences could be, for instance, the anthropogenic emissions of greenhouse gases that are changing the balance, the radiation balance in the atmosphere, and the how it is affecting the ocean and other components of the climate system. It could be other natural forcings like volcanoes, or it could also be that factors like the El Nino Southern Oscillation, for if we are interested in producing information for the next few months up to a couple of years. Somehow anything that is influencing for a sufficient time the Galton board that we have in the climate system, we should expect a change in the distribution of the potential futures that we are going to experience. And that's what we are trying to estimate with all the experiments that we are running about the future, to estimate the future climate. So I mentioned, for instance, the role of the anthropogenic forcings. We have different possibilities for the evolution of the anthropogenic forcings at the global scale. We can consider green transition scenarios like the SSP1, SSP standing for the kind of socioeconomic conditions that are going to define the emissions of anthropogenic gases into the atmosphere. So the green transition scenario is it has a low challenge for adaptation and for mitigation, and it corresponds to lower emissions, while other scenarios that basically implies regional rivalry and the continuing emitting into well, as much as we can into the future, or need into the future, are pose larger challenges both for adaptation and mitigation. It's important to bear in mind, and our colleagues tomorrow will insist on this, that for the next 20 to 30 years, the evolution, the difference in the emissions and the concentrations of greenhouse gases in the atmosphere, depending on those different scenarios, are not going to be very large. So we can focus on other drivers, like, for instance, as I mentioned before, the possibility of the occurrence of a volcano. So, for instance, if a volcano, an explosive tropical volcano goes off in the next few days, months, or years, we need to be ready to prepare to run again, to produce new climate data that will support the decision making for a world that over a few years, like it occurred during the eruption of El Chichón, as you can see in the panel here on the bottom right, cooled down the atmosphere for a few tenths of a degree over several years. And all this information is being gathered by operational activities that follow conventions that the World Meteorological Organization is setting. One example is the decadal prediction information that is being delivered by the Lead Center for Annual to Decadal Climate Prediction that you can find on the web. But there are very good examples from the Copernicus Climate Change Service in terms of the production and delivery of seasonal forecasts. So what to do with all this information? So somehow we have a number of users that need to make decisions that are very complex and that at some points are using climate information. This is one example of one of the super users from of the Aspect project that has to that is confronted often with different decisions in their business that affect different parts of the cycle. So some decisions have to do with the protection against spring frost. Others have to do with the decisions that affect investments to ensure water management. They have many other decisions that they have to make. So somehow we are aware that climate is only one aspect that enters very complex decision processes that are performed and faced by both the public and private sector. And that means that we need to work with them to not only provide them with the kind of information that we think they need, but try to really go backwards and forwards, as this cartoon is trying to illustrate, to understand in what way in what format they require the climate information, and how we can fine-tune the climate information based on the climate data that we have at hand, in particular the climate predictions, to address the actual problems that they have. So somehow the community, and in particular the Aspect project, is running away from this concept of we produce the data, here is the data, you should be okay. So it's actually the other way around. So tell us which data you need, tell us which experiments are really relevant to you. We'll try to make the most, not just to run the experiments, but to try to explain to you what you can expect in terms of quality from this climate information that we are going to deliver. And these are examples from a couple of partners of the information that is being prepared and co-produced with Codorniu for this case study for winemaking in the Catalonia region. Just getting to the end of the presentation, I couldn't finish the presentation without mentioning climate services. So many of the processes and decisions and developments that are being developed and are taking place in Aspect are part of a climate service. They contribute massively to the development of climate services from the research point of view, and they take into account that the usability of the climate information, its usefulness depends on the ability to move towards a demand-driven perspective of the co-production of climate information. And the objectives are to enhance three aspects: the credibility of this climate information, the salience, so basically the usefulness, how useful it is for a specific user, and the legitimacy of the information that is being delivered. So how credible and how legitimate the producers of the climate products are. And this is somehow one of the elements that will contribute to one of the big initiatives that the World Meteorological Organization, along with other UN agencies, is trying to put together, in particular to support climate adaptation and disaster risk management in developing countries, which is the Early Warnings for All initiative. All this is very good, but it's very important not to be overconfident with the information that we are delivering. To produce the kind of information that our users are actually expecting, it's indispensable that to take into account that both climate models and observational data have problems, and they have some sources of inadequacy. So that makes that our uncertainty estimates could be not sufficiently credible, and that might affect any risk assessment or any climate adaptation decision. There are two elements that I'd like to mention at this point. The first one is that to reduce this overconfidence or underconfidence on the information, we need to address very seriously an aspect which is the quality assurance of this information. There is a project, the Climate Europe 2 project, another Horizon Europe project-like aspect that is trying to identify what are the elements in the production of climate information and the delivery of services that should be recommended for its standardization by standardization bodies like ISO or WMO. Somehow, what we need to bear in mind is that the climate information that we are delivering and that will be delivered by operational climate services are going to be is going to be used to make decisions that might put lives at risk, and that means that we need to be very, very serious in terms of identifying what are the secondary effects of the decisions that will be based on this climate information. And I included here one of these information sheets that come into any of the medicines that we buy in the pharmacy. In this case, it's from the paracetamol. Nobody sensible would take a drug from the pharmacy without having this piece of information. And there is no reason why it shouldn't be the same for the climate information that is being produced and delivered. And the second element that I wanted to bring in is that there are many aspects that we ignore or that we are still formulating in a very ambiguous way. And Andy Stirling, already 14 years ago, I formulated this in a very enlightening piece in Nature, where somehow he warns that we pay a lot of attention to risk and uncertainty because these are somehow unproblematic in terms of the possibilities for the future. But somehow there are other more problematic possibilities which have to do with the ambiguity in the formulation of the problems that we are dealing with, and the ignorance that we have in terms of the actual climate system, or the ignorance in terms of what is actually relevant. And this is only one example out of many of these aspects that we still ignore. This is at least an aspect that we know that we ignore. There are many others that we ignore. And in this particular case, it points at the relevance of, for instance, including the meltwater from the iceberg, from the ice sheets in Antarctica that is falling into, it's coming into the Antarctic circumpolar current, and can actually slow down the transport in the current, but it can also affect places as far as the North Atlantic as early as the beginning of the 21st century. So just to say that the climate information that is free is no good if it doesn't come along with quality estimates, and if it doesn't warn you about the things that haven't been considered yet because we don't have the capability or because we are not sure about what we know yet. And I'll leave it there. Thanks very much. I'm very sorry if I went on for too long, and I hope that you found it interesting. Thank you.